Hello, my friends of Katri Labs. My name is Montoya. Welcome to this tutorial. In this tutorial, we are going to do this kind of models. Okay, this is a Voronoi meshes, MF6 Voronoi mesh models, but we are going to do this with the use of templates. Okay, so with the use of template, we are going to accelerate our workflow. So let's start. So you are going to receive on this, I'm going to close this as well. Okay. In the description of the video, you are going to receive the link to download the this zipped folder. Okay. And please place it under your documents and start a Anaconda Prom CD documents, CD accelerate. Okay. And then here we type Jupyter Lab. And why the use of templates? Because when we talk about templates, when we talk about models with profile, 80% of the code is actually the same. So for that, we have created some templates. Okay, so you are going to see this notebook generation notebook. Okay, that actually calls a kernel clear outputs. Okay, so well, you have template to generate the Voronoi and the template for Voronoi creation. Okay, so we are going to run this, and this. Okay, there is also a template for observed calculation, but this is for another tutorial. There are some warnings that maybe is related to some version of Modflow 6. But what this code does is actually creates two new notebooks. Okay, so you are going to see this, that it has created two new notebooks with the prefix, and this is the prefix regional. So this is regional P1 and regional P2. Okay, and what we have to do is just we have to open the regional one. Okay, great. So, and then we have to run it. Okay, so we are going to run it. First, we run this cell. Okay, whatever is on the template is with original. Okay, so the model will be a regional model. The maximum reference will be 250, and the shapefile will be of 100 meters. Okay, so there is a limit. Okay, and the catchment. Okay, for that you need to have the shapefile of the catchment and the river basin. Okay, so we run this. Okay, so we generate the point cloud and the Voronoi. Okay, we generate that. Okay, it's on the generation, and from there we create the Disv, the shapefile, because actually the mesh will be stored on a shapefile. Okay, so let's wait till let's wait for that. Okay, okay, so it has finished and it has 8,000 cells. Okay, so it will save under the output folder. So it will save it here. The mesh will be saved here on the output folder, and it takes some time. Okay, so 2 seconds, and then we can, from the output folder, we can call the mesh, and this is the mesh that we have created. Interesting. Okay, now we open the mesh. Okay, and get the properties of the cells. Okay, and with that we go to a JSON file, and then we save the properties of the cells. Okay, why? Because to this point we have the properties of the cell stored on a JSON, and we are going to, okay, in the next part we are going to open the this JSON, this dictionary, and we from the dictionary we are going to import we are going to create the grid. Okay, so okay, so we open the next. Okay, so we are going to open the next the P2. Okay, great. Okay, so we run import the required packages. We import the Disv JSON, and then we turn this into properties. Okay, we open as well the them, and then we extract the elevation over the cells. Okay, great. And here, mhm, the elevation, the bottom elevation is actually 3,100. Okay, and the rest remains the same. Okay, great, great. And well, this is for the sim generation, and this is the temporal discretization, and this is the GWF. And here on the solver, we are going to have a change from the template because this will be 100 and this will be 100. My recommendation is if this is your change, just take it out this commentary that is from the original file. Okay, so this is the Disv. Okay, this is the discretization. These are the initial conditions. That is the mtop. Okay, these are the the XT3 options. We are not going to use the XT3 option, so we take that away. Okay, and the storage, well, is in steady state. Mhm. Okay, and then we apply the recharge and the evapotranspiration. We define the intersection object. Okay, and then we apply the rivers because the rivers are here. Okay, so these are the cells that intersect with the rivers, and then we apply this to the river network, and then we can plot here the river. This is the river network of our model. Okay, so we set the output control. Okay, and then we read and write the simulation. Okay, if your model differs of what is here, okay, what you have to see is you have to tune the script, but this script tuning is actually pretty faster to do it in this way than to type it from the beginning. Okay, great. So it has a normal termination, and here we can plot where we only have one stress period time step. This is the time step, and this is the final representation of the regional model that has MF6. Okay, as you have seen, is really easy, and I will strongly recommend to follow this tutorial to get to know the procedure, and based on this procedure you can actually apply that to the models to your model, and there will be more templates, and each template will be actually addressing one type of model. So wait for more tutorials from our side, and please have a great day. Bye bye.